Hi, this is Adi Boris here for CG Masters, and today I'd like to take a look at creating some procedurally generated cracks and scratches for our cycles materials. This is a method that won't be making use of any UVs, so that should hopefully speed things up for us. And talking of speeding things up, I'll be making use throughout this tutorial of the Node Wrangler add-on, which we can see if we launch into our user preferences with Control Alt and U. You'll see that I've filtered out all the add-ons available that we can see in the right-hand side list here, just to the node-related add-ons, and that makes things easy because there's just one in here at the moment, and I've just enabled that there. And that means we can go Control Space and get a whole load more options within the node window here, and also we've got it if we use our properties sidebar with the N key. The main use of that I'm going to be making of this is the speed up in workflow of being able to visualize what any single given node is actually doing. So we can go Control Shift and left click on this. It will immediately plug us into an emit shader so that we can easily see exactly what's happening on this material demo object that we have over here. If we continue to Control Shift click on the node, we can then toggle through the various outputs. So instead of seeing the cracks output, we're now seeing the scratches, which incidentally is simply an inverse of the cracks. And then we have our worn edges, which is essentially like the scratches, but they're just kind of blurry, and then the interior of where the cracks were are all masked out. We of course can see some various options in this group, so let's just quickly tab into this group and we can see the interior, and it's actually not that complicated. It's a little bit messy in here at the moment, which might make it look more complicated than it really is, but we'll soon find that this is fairly straightforward. So tabbing back out of the group there, we can take a look at the controls we've exposed outside of the group. So we have this scale now, so let's take a look at the end result for a minute. Let's take a look at this node where we've not only multiplied the cracks onto the green color, we've also added in the worn edges as well. I'm just going to turn that up to full so we can completely see what's going on. One other thing, just before I go through what options we have there, is to make note of the fact that I've duplicated another version of this. It's taken the mapping instead of the UVs out of the object, which is going into this mapping node, and this mapping node isn't doing anything. But this one has just got some slightly different rotational values just to add some variety to how the cracks are displayed, as well as probably some of these settings are slightly tweaked as well. Just to make things a little bit clearer as to what's going on, I'm going to reduce the cracks of the second node and also the worn edges of the second node, and that should just leave us looking at the results of just this one instance. So we can manipulate the scale, so we can turn that up, which means you're kind of going to get smaller and smaller cracks kind of appearing, or at least smaller and smaller segments. And we can take that right down to about 1-ish or so, 0.1 for very, very large cracks. And then let's just take that to somewhere in the middle. So something like that. And then we've also got access to some thickness. Now you have to be quite careful with this because it's very easy to break. But if we just kind of do a little bit of thickness there, you can kind of see the effects that we're getting there. And then we have our cracks mix. Now at the moment we can kind of see these entire areas, but we can kind of reduce this and it'll look like our cracks are much more broken up. So we don't have various islands of cracks, we just kind of have seams running through randomly. Then we have our noise, which is adding distortion to the edges of the cracks, so that if we turn this down to 0, we're basically getting very, very straight edges on our cracks. And then the noise scale and noise detail are related to the way that that noise is used. And then we have our worn edges, so we can spread that out a little bit further, as you can see there, or we can tighten that in. And then this worn edges fade just allows us to either bring it right back in so it's at maximum intensity or completely fade it out on the node itself. So we can either choose to simply multiply on our cracks or add on our worn edges, or we could, instead of using them as color information, we could use them as masks. So if we plug our cracks into the factor of this color mix node here, and then plug these two textures that I have over here from CG Textures. I've just got an arbitrary choice here really, but we have the bark deciduous, which I've darkened down a little bit, and let's put that in the first socket, so wherever there's black in the mask that will show this texture. And then over here we have just a simple metal base texture, and I can plug that into the second socket, and then let's just click on that now. And then instead of it being multiply, let's set it to mix so the mask can have its proper effect. And you can see now we're kind of getting this mixture of these two textures instead of it being just a simple black being multiplied. I've also got, if I unplug the color from the diffuse shader and then Control Shift click on the shader just to plug it back to the material output and remove our temporary emit shader setup, we have the cracks plugged into a bump node, which is then plugged into our normal of the diffuse, so we can kind of see the effect of that there. And it's on full strength and distance of 1 at the moment, so we can easily reduce that effect if we like. And just to orient ourselves to the scene a little bit, I'm just going to plug that back in though to the diffuse color. This material demo object is about 1/4 meter across, so if we cupped both hands we could probably comfortably lift up this object. And then on another layer I have Blender's monkey mesh there, Suzanne, to demonstrate these cracks. And we also have on the third layer something with a much more flatter surfaces to it, so much more boxy looking. And if I actually just toggle into wireframe with the Z key, we can zoom out a little bit quicker here. Take note of another object just sat next to that, which is basically about the size of a door. And you can see the material applied to that. You can't see very much from this distance, but if we zoom in a little bit, we can kind of see how that object is appearing. So let's toggle back into the wireframe, and I'll click on the first layer again just to reorient ourselves onto that material sphere there, and then Shift Z to bring us back into rendered mode. And now what we'll try to do is rebuild this texture, this procedurally generated cracks, and explain the hows and whys as we go along. So here I have the material demo object with a very basic default diffuse shader applied. Now we'll build back up the cracks node group with the settings that we need. First of all, we'll need to create our cracks, and for this we'll need a Voronoi texture, so we can go Shift A to add it in, and then find our textures, and then Voronoi texture, and then just left click to drop that in. Then what we can do is just bypass our diffuse shader entirely by just Control Shift and left clicking on it, and that will automatically set us up a temporary viewer node, which is basically just an emit shader, and that allows us to represent very clearly on our material demo object here exactly what this node is doing. Now this is pretty close straight away. We get these kind of white cracked lines, but they do fade off quite a lot into these sort of black inner circular cellular things. So what we might like to try is to plug in a color ramp, convert a color ramp node, and then plug that in between the output and the Voronoi texture, and then grab the leftmost black flag of the color ramp and then try and squeeze all those black values in, so we're just left with the white pretty much. But as you can see, that isn't really very helpful. We're just getting that dominant sort of circular pattern. So we're going to need to delete this. I'm just going to use Control X just to maintain the network there otherwise. So what we're going to need to do is switch from intensity to cells, and this is a point that we'll come back to in a moment, but this, as you can see, is coloured, and that's because the output of this is a yellow colour output, which means it holds 3 values, one for the red, one for the green, one for the blue. The factor output, however, is just one single value. So if we Control Shift click on this texture again, this node, you can see that it switches over to a factor, and we can see that it's represented by grayscale because it's only passing out one value, which is getting sent into all color channels. So if this was 0.2, for example, it's going to be 0.2 for red, green, and blue. So no color is getting any emphasis there, basically, which is going to just result in a grayscale image. Now that means that we can actually just plug this straight away into the displacement if we wanted to, and I'm just going to plug the diffuse back in so we can see this a little bit clearly. And that would basically give us the cracks that we might need in some circumstances. It could really be that simple. And then we can just change our scale values and kind of get a little of what we need. The downside to this, obviously, is the fact that we're not going to get any of our worn edges. We're not going to get anything that we can use as a mask. We're not going to get anything that plugs it into any sort of texture information, really. It's just going to be this simple displacement. Also, you can see one other issue, which is what we would have with anything that we would plug in without any mapping information, is the fact that down at the bottom here we're getting quite squished coordinates, and that's because this object down at the bottom is different than this object. The bounding box for this object is quite even, whereas this one is very, very shallow, but it's quite wide and deep otherwise. what we're going to need to fix that is to add in some texture coordinates. And so what we can do there is go Shift A and add in an input and texture coordinate. And then what we can do is plug in the generated. That's the default. It's already assuming that this is using generated coordinates, but we don't want that. We want to use our object coordinates instead. And you can see they're very, very different there at the moment, but at least it appears to be fairly uniform otherwise. This will become a little bit more noticeable if we crank up the scale of this. If we wanted to shift any of the scaling without altering this value, we could do that, of course, by going Shift A and adding in our vector mapping node. And then instead of using the scale here, we could change the scale here and actually adjust our coordinates. But we're just going to leave this as blank for now, as we'll be coming to this in a moment. And as another aside, we can actually delete those with the X key and then set that up automatically with the Node Wrangler add-on by just highlighting the texture and then pressing Ctrl T. That will set those two up for us, and then we can just switch to the object. So let's Control left click across the displacement there, because we don't need that plugged in anymore. And I'm just going to Control Shift click on this Voronoi texture again, and we can start to build up our cracks that we can use for all those other methods that we were talking about. So to turn this into something that we can use, we're going to need to duplicate our Voronoi texture, which we can do by going Control Shift and D, and that's going to maintain this incoming connection to this. And then I'm going to mix these factors into a color mix RGB node. So I'm just going to pull that out of there, plug that into the first socket, and then this one into the second. And then Control Shift click on this color mix node to see the result. Now obviously there's not going to be any changes between these two right now because they're identical, but if we set this to subtract, we're going to get a darker representation of what's happening there. And when we turn this to 1, it's going to be completely black. And just to explain this, it's kind of pretty simple really. The white values, which are represented as 1, or at least close to 1 anyway, and the black value is close to 0, we're basically just getting 1 subtract 1, which is in the same location, is going to equal black, or 0. And 0.2, where it's darker, subtract 0.2, and you're going to get black, or 0 again. Now if we actually change the scale of these slightly, so this is 29.7 instead, we're getting this slightly offset area, and now what's happening is you're going to get a little bit of white overlapping where on the first one, where the second one is actually black. And now that's going to be 1 subtract 0 is going to be some value. Well, obviously that's 1, but you know, in most cases it's going to be some value above 0, which means it's going to show up here as some kind of crack. Now, the way in which we can advance this a little bit further, because we're getting these sort of broken up cellular patterns at the moment, which is pretty useful, that's pretty cool. We can actually further this slightly more by taking these and then selecting those 3, which is basically creating our cracks right now. We can then go Control Shift and D just to duplicate those down, and then let's duplicate one of these color mix RGB nodes, and then instead of this being 29.7, or at least 0.1 above in the scale, I'm actually going to set this to 0.1 below the scale, and now plug that one in, and you can see we're getting a slightly different array of cracks there. In fact, if we add these now together, so we take that one and then Control Shift click on this, we pretty much get the majority of the cells that we had in the first place, but now we have control over the thickness to a degree based on the distance between these two values. So we're not going to do it via the scale, we're instead going to do it via the mapping, but I just thought that this was the simplest way of being able to demonstrate what we're doing here. So instead of adjusting the scale, let's set up the slightly more difficult to explain way in which we're actually going to do this. So first of all, I'm going to change all these scale values to be the same value. Now the easiest way to do that, and the way that it's going to give us the most control, is to just add in an input value node, and this one I'm going to set to 29.6 and then plug that into all these values. That way when we change the value here, it updates for all of those sockets. Now as you can see, that's going to set everything back to black because these are all now the same scaling value. And the next thing we need to do is change our vector information. So I'm just going to drag these over here, and then I'm going to left click and drag across all those nodes to add in a reroute node, and then I'm going to right click and then drag that down a little bit in between these like that, and let's pull that value out a little bit. I'm going to right click that reroute node and just label that as vector so that we can see what's going on quickly there. And the other thing I'm going to do is I'm going to bypass sort of this addition so that we're really only just looking at the results of these kinds of nodes at the moment, which leads us here. So I'm going to Control Shift click on this one. And so if we're going to keep the scale the same on all of these, we need to adjust the vector position of this second one. So let's do that. Let's pull this a bit further out actually. I'm going to use a Shift A, add in a converter, and then I'm going to add in a separate XYZ and a combine XYZ. And let's plug that in before here, like that. And let's plug this in afterwards, if we can find the socket. Let's make it a little bit easier on us by collapsing it with the H key, and then press H again to uncollapse it. And then basically, I'm going to recombine these again. And then now nothing has changed. Basically, the vector information for this second one is exactly the same as this one, because all we've done is separate them all, do nothing, and then combine them all again. So just to backtrack a little bit to explain what we're doing, this blue purpley output socket is representative again of 3 sets of numbers, similar in the same way as the color is for RGB values. This is generally represented as holding X, Y, and Z coordinate information. The thing is that this is pretty much just maths, and so we can mix and change these sorts of nodes with color mix RGB nodes if we like. It's just that this seems a little bit more intuitive when we're dealing with X, Y, and Z values rather than trying to manipulate colors, as it were. So in this case, what I'm going to do now is I'm going to go Shift A and add in a converter math node, because I want to shift everything ever so slightly by some thickness value. So I'm going to set that thickness value to be very, very low at the moment, so something like 0.001, and we'll add everything in. So again, I'm just going to make things a little bit easier by pressing H to collapse, and then I'm going to drop that in on the first one, and then I'm going to, and in fact you can already see we're getting something showing up now, and then I'm going to Shift D to duplicate that and drop that in for the second one, and then Shift D to duplicate that into the to the Z value, the third input socket there. And then now these 3 areas of this little calculation here are sort of just adjusting this Voronoi texture position ever so slightly. And so what we want to probably do instead now is press H to unhide all those, and instead of manually adding in again as we were, the same reason we've added this in, let's Shift D to duplicate it, let's plug 0.001 into here instead, and then plug all those in. So 1, 2, 3, and then let's collapse these again, and let's neaten this up. So now we have the adjustment of this. Now we can do the same thing for the bottom series, so I'm actually going to Control Shift click on this bit again so we can get the combination. And what we want to do is to basically do exactly the same. I'm just going to Control and Shift D to duplicate these down and put them there. This value is kind of getting a little bit strange already, it's getting a bit complicated looking already, but that is fine, that is fine, that is fine. But instead of going into nothing, we want this to go into the second Voronoi texture here, and instead of it being an additive, we want to subtract from all of these. So I'm going to press H to unhide all those and just shift these to be subtract instead. So let's just do one of these one by one, and the same here, subtract. And then let's again neaten this up a little bit. And as you can see in the 3D view there, we're now basically getting what we want. And now we have these 2 values which are essentially controlling the scale of the cracks. So we can kind of make these larger I should say make this kind of amount of them larger, or we can kind of make the cells themselves larger by reducing this figure. And then we can increase the thickness size by increasing this value, or we can drop it right down to 0.001 or even lower. And that is basically our cracks. Let's just pull these out a little bit further. And there's a couple of other things that I'd like to do. I'm just going to shift select all these and press G to move these out of the way. And there is something else that I'd like to do at the end here, which is add in a color ramp node and then just take the white flag on the right hand side and just squash that down so that we're getting a much more predominantly white and black kind of squashed in image there. Let's just set the position to it to something pretty close to where the black is, something like 12. So really close there. And then finally, for our cracks, we don't want white on black, we want to invert this. So I'm just going to go to color and invert and then just drop that in at the end. And now you can see we're basically getting our cracks. So that is the node setup for what we're going to do there. And to clean things up a little bit, what I'm going to do is just, I'm going to border select with the B key across all those nodes. And then, in fact, let's add the value nodes in there as well for the moment. And then I'm going to press Control G. And now if I tab out of that, we can see the simplicity of what's actually happening now. And then I'm going to tab back into it again just to help things with how we can lay all this out. Now we have this input here. This at the side in the property sidebar, which we can toggle with the N key. We can see we have this input here. I'm going to change that to vector. And we want these values as well. So let's control and left click on this and then plug that into here. And then you can see we get our scale there. I'm going to set the scale to be a default value of 21.4. And also, instead of it being scale, I'm just going to call it cracks scale. And let's give it some minimum and maximum values. So something like 0.1 maybe to 60 perhaps. And let's see. Let's tab back out and see what we're getting. So that's starting to show up nicely now. Let's just call this cracks. That's fine, and then tab back into it. And then, so that's now sorted. Let's delete this with the X key. And then I'm going to control left click on this and then drag that into the next available socket. And instead of it being value, it's going to be cracks thickness. And the default value is 0.001, which is fine. And then let's say the very, very minimum is say 0.0001, which is super small. And then let's just set that to 1 for now because I'm not too sure what the highest should be. The color output, that's this over here. I'm going to name that as cracks. And I'm also going to take out the uninverted version and plug that in, and that's going to be our scratches. If we zoom out a little bit, we can start to see what's happening now. So I can take this and delete it because we don't need that anymore. And this vector here is fine. I can plug that in there. And now what I'm going to do is I'm going to grab all of these in here, and then I'm going to press Shift P to basically parent them all to this frame here. And so then I'm going to call this, by writing in the label section here, I'm just going to call this cracks. And then let's tab back out of that. And now we have these basic values on the outside of this. One more thing that we can add to the outside of this node group is the control on building back in the more complete cellular crack pattern rather than it being more fragmented. So what I mean by that, if we just tab back in, is the control of this final add here. So if we watch what happens when we back this back off again, you can see it's basically become much more fragmented. So let's control this outside of it as well. And for that, I'm just going to make this full screen a second so it's just easier to do. And let's plug from here into that factor. That factor there we're going to call cracks mix. and just leave it at that default value of 1, and then between 0 and 1 is fine. So let's review our original shader that we're building back up to. If I tab into the node group here from the original situation, you can see that the contents of this frame is what we've essentially reconstructed, and then the contents of this frame is actually pretty much a duplication of what's happening in here. So you can consider the lion's share of this pretty much done already. The next thing that we need to look at is the noise, the distortion that we're adding into the vector coordinates, just give that sort of natural waviness so that we're not getting just straight cracked edges everywhere. So let's address that in our shader network that we're building back up for our texture here. And let's tab into this and then give ourselves a little bit more space, and essentially we're going to add in the noise before this main vector detail comes in and informs where our cracks are going to lie. So I'm going to go Shift A and add in a texture, noise texture, and at the moment if I just plug this straight in here, you can see that we're plugging in vector information, but we're actually taking out color information. And as I say before, the blue sockets are just this X, Y, and Z detail. And instead of it being X, Y, and Z, we can interpret the RGB values that come out of the yellow color sockets as basically just the red channel is going to inform the X direction, and the green channel is going to inform the Y direction, and the blue for the Z. So these are sort of interchangeable, and we can get some interesting effects to the vector coordinates by doing this kind of thing. But we don't want to just go crazy with this. We want to be able to reduce this effect right down. So I'm going to add in a color mix RGB node. I'm going to plug this into the second socket and our original vector information into the first, and then just take this to add, because we're going to add the coordinates in, but we're just going to take that down to 0. So that should be our original cracked pattern that we're used to. So far these two textures, these two nodes I should say, aren't doing anything. So let's just review what we've got here. We've got the vector coming into the noise texture, which isn't being mixed into this whatsoever, so it's essentially ignoring it. And then we have the original vector information coming into here, which is essentially being passed out unchanged into this vector thing, which we're used to anyway, and it's informing the rest of it. So what we can do is start to add this factor back in, and you can see we're going to start to get a little bit more waviness to the cracked pattern that we're getting there. The only problem may be that this scale is maybe a touch low, and so we're not really getting that much of an effect. But as we start to increase that, you can see that you get a lot more of an interesting pattern starting to emerge. The problem is, if we set this back down to something low again, you can see that we're starting to get a little bit of a shifting. So everything's just moving in the same direction. And we might be actually quite happy with where this is at the moment anyway. So we just want to sort of add waviness to where the edges sit and not have them sort of drift off. And thanks goes to Bartek Skrupa for laying this out so clearly in the Blender conference. Also, thanks goes out to Greg Zahl for laying out this kind of adding in the noise detail to your vector coordinates to get this kind of interesting randomness going on. So thanks to those guys, but hopefully I can just quickly explain what's happening here so it's not just too much of a mystery. But anyway, as I say, we're adding this in and it's shifting, and that's because we're getting values out of the noise texture which is from 0, which is black, to white, which is 1, and we're always adding these, so we're not getting any negative values whatsoever. So what we might want to do is remap what's happening from this noise texture. If we just use a converter math node and set that to 0.5 and then subtract 0.5 from that, we should basically get what we want, and you can see there most of it is sticking to where it should be. So just to sort of try and hammer this point home, the texture information from here is now going from minus 0.5 to plus 0.5 as it exits this node, and that's being added back on. So what's happening is a lot of the values are falling around what would have been the mid-gray from out of here, which is being added, readdressed as being around the black value here, or around 0, and that means a lot of it isn't actually going to shift one way or the other. but some of it is going in a negative direction, which is going to wave it one way, and then the positive values are going to wave it more down this sort of a direction from what we could see. So if I just add the increase the scale there and just start to add this in, you can kind of see a lot of what we're getting now is sort of maintaining its original position. So I'm hoping that that's clear. I'm just going to select all these and go Shift P to parent them to this frame, and then I'm going to call this noise. Now, to give ourselves some controls from this, I'm going to plug in the scale and the detail, and the scale and the detail can be noise scale, and that can go from, say, let's just say 0.1 to 60 might be a good range, and detail, this is the noise detail, and that will be a default value of around 2 is fine, and I'm just going to lock that at 5. So there we have the noise. We can add that in now, and we could tab back out of the group, and we can see we've got another couple of details there, and then we can potentially increase the scale and increase the, we have of course forgotten the most important, which is this factor. So if I just plug that in, this is essentially the noise strength, and I'm going to lift this up above the others just to try and insinuate some kind of importance there. Noise amount, let's say, and let's set that between 0 and in fact things get pretty crazy pretty early on, so I'm just going to lock that down at 0.5. So if we get the noise amount and start to bring that in, you can see we're getting something fairly decent, and by the time you get into 0.5 things are going pretty haywire, but you can always set that to whatever you choose. So now we need to just address our worn edges, and then we're pretty much done. So let's take a look at our original texture node group setup by tabbing into it, and you can see we've covered this bit. This is the noise that we've just been looking at over here, and now we have our worn edges, which is a duplication of this, so we can see we're nearly done now. We basically need to blur the vector now to get our worn edges. Now note that this is basically the same as our noise here. We have a noise texture, subtract 0.5, and then add the results of that back into our vector, and this basically the same is happening here. We have a noise texture, we have that subtracted so that it doesn't shift at all, and then we have that added back into our vector information, which is then plugged into everything down here. So let's duplicate that sort of idea in our texture node group that we're building back up by tabbing back into here. I'm going to grab those three, press Shift D to duplicate them, and then Alt P to just unparent them from that particular frame, and then Shift P to add them into a new frame, which we can label as blurred vector. And from this we're going to need to take in the vector out of the distortion though, so let's plug that into our noise, and then we're also going to need that to be plugged into our add node here, which is basically means that at a value of 0 that it's basically not going to blur anything whatsoever, but we still need this vector information. Now this needs obviously something to plug into, so let's just border select all that with the B key, and then go Control Shift D to duplicate that all down, and then let's relabel that. Instead of it being cracks again, we want worn edges, and what we want is an output of this, which is going to go into another spare socket there, so we can call that, instead of color, we can name that as worn edges. In fact, let's tab out of the group and then Control Shift click on this node that we have now, just to toggle through into that worn edges. Now worn edges, we don't want to be black cracks on white, so we don't need this invert node anymore, so I'm going to go Control X to delete it, and you can see we get something which now looks like the scratches, but we want to be able to blur this, so let's come over here and see what we need to do. We need this blurred vector to inform the position of what's going on in here. So we can basically, I realize this is getting really very spaghetti-like in here, but this vector information that's being pulled down into this group, I can cut across. I don't need it. So those three I can get rid of, and that one there I can get rid of as well. Then we need to replace what we just cut there with this. So let's just plug that into that, and that into that. So obviously we're still not quite getting the right result here, so we need to plug it into a couple more places, into here, and then into, whoops, and then take an out of that and plug that into there. And now we're getting our cracks again. So that should be now working. We're basically getting this noise texture. Now we don't need any detail on here. And as we add this in, obviously not much is happening. We're still getting that sort of wavy sort of change to everything there. But if we set this up to say 50 and then start to do that, you can see we're getting something a little bit more like that. And then set that up to 100, you can see we're getting this. And then if we take that up to 1000 and then start to do that again, you can see we're starting to get something which looks kind of a little bit like blur. So if we kind of come in a little bit more, you can see actually what it is just very, very high amounts of the noise there. The scale of it is obviously very high. So if we just try 10,000 instead, you're getting pretty much what happens to be a blur. And again, thanks to Bartek's Garupa for laying this out at the Blender conference. Then we can just add that in, and you can see it's just spreading it out even further there. So what we might want to do is take the add of this, the factor value of this add node, and plug that in, and that factor will be the noise spread, and we'll set the default value to something like 0.2 maybe. And let's tab back out of the group and take a look at what we've got. So noise, we've got this noise spread. In fact, let me just name that. Instead of it being noise, let's make this a little bit more clearer as to what's happening here. This is worn edges. And then let's call that worn edges spread or size or something like that. So let's take this and then spread that out, which is fine. Like that. Now obviously we don't want the interior of that, so we want to mask out the cracks, so let's set that up, but we can do that after this frame here. We can go Shift A and add in a color mix RGB node, plug that in to there, and we want the output of this to be multiplied onto it. So let's change that to multiply, and then you can see we can set this to full, and then we have that basically masked out. Now there's one more thing that we can do to this, which is to add in another color mix RGB node after this, and basically just multiply in a black color, which the higher this value becomes, the sort of more we can reduce the overall effect. So let's plug this value into, in fact I'm just going to speed things up a little bit in the window here by just toggling into wireframe for that, and then grab that factor and plug that in at the bottom there. So that can be our worn edges amount or strength or something like that. In fact, because the higher the value is, the lower the effect, let's just kind of call this worn edges reduce. That is the majority of all the controls and so on that we had in our original network. Let's just, as one last thing, add this into a color mix RGB node outside of this, and then set that in the second socket. In fact, let's take the cracks out of this instead of the worn edges, and then cut across that with Control left click across it, and then set that to multiply. Let's set this to a green type color, maybe a little bit darker, and then multiply that as full. So that's our cracks. Let's add in a little bit of noise to this as well, just a tiny bit, something like that. Maybe set the scale a bit higher as well, actually. Maybe something like that, and then reduce the noise back down again. So something like that I'm reasonably happy with. Then I can duplicate that with Shift D, plug that in afterwards, set this to add instead, because we can take our worn edges out, and then add that in, and then maybe just reduce the effect here if we want to. So let's just pull that down, and there you go. In fact, actually, let's just bring this back into it. So let's plug that into the color of our diffuse output, and then Control Shift click on the output of the diffuse, and you could see we're now removed the emit shader, and now you can see it properly on the demo object here. We can also see it on the monkey now as well, having been built back up, and we've got it on our more flatter surfaced objects in this layer. So I hope you found that useful, and for more information you can pick through the node layout on the CG Masters page with this video, along with a blend file available for download. And if you do make use of this idea, please let me know. I'd love to see the results, and if you develop this further or have any ideas, of course, please let me know that too. So that should wrap things up for this video, and thanks for watching.